engineers, researchers, data scientists we have in the grad. That's pretty rad. It's pretty fun show. So today we're here to talk about interoperable standards. It's kind of an interesting thing because, like, if you think about blockchains, like all these protocols, they work because people just agreed on a standard. And when I say work, they work obviously on a technical level. They're able to reach consensus on the state of a ledger, but they also seem to work on like an economic level. That for some reason people are incentivized to keep spending their valuable electricity and using their valuable CPUs to create hashes and just keep trying to like create blocks in whatever chain they're mining. And we're seeing like more and more sophisticated kind of versions of that as we go. And so to me that's really interesting because it's really a space that's obviously not built on standardization, right? Because there's amazing amounts of diversity and innovation in the space. But it's a space where people have to kind of agree on standards at some point. So I guess we'll start with you, Eugene. So you've done a lot of work in supply chain, you've done a lot of work in IBC around cross-blockchain communication. Can you tell us a little bit about kind of, in whichever area you want to start with first, kind of the value you see in people eventually agreeing on some kind of protocol that you use to kind of communicate between systems or even like between chains?
I think the first thing you kind of want to start talking about is the use case, right? At least from the implementation standpoint, that's the first thing that you want to start with to understand what you're trying to build. So the internet of blockchains. So the use case that, for example, that I envision is, an ability to transfer. The most obvious one is to be able to transfer tokens between the blockchains and continue the lifespan of those. So, for example, if I have a Bitcoin and I want to run a smart contract on the Ethereum blockchain, I should be able to take that Bitcoin, move to the Ethereum, run a smart contract, or then maybe to jump to another chain where I can.
Right, that's really important because I'm sure, like in traditional systems, you've seen how if you have two like databases, they're not talking to each other, right? Then like, how are these two companies going to work together?
Right, so I want to be able to run, blockchains are certainly going to become and already are becoming very specialized, right? So be able to take the coin, transfer it to another blockchain, do something with it that's specific to that blockchain, and then move it back to another one, and then maybe circle back all the way out, back to the, the original chain. That's a valid use case, right? For example, I want to take the coin, go to the gambling chain, do some games there, win some coins, bring it back to the Zcash and make it zero knowledge coin, and then send it back to me, right? Into the Bitcoin, for example, right? Right now, it's all going to require essentially individual development paths, so on and so forth. The vision of the future where you can have the standards where that can be a seamless transaction between all these chains, with resolving double spend issues and so on and so forth. That's a great future, right? And that's a very valid use case. So how do you accomplish this without building individual connections between, Zcash and Ethereum, or Ethereum and Ethereum Classic, for example, if you wanted to move that? Is there a common protocol? Well, certainly, a lot of folks are working on the ideas behind that right now. There's a lot of progress is being made by a number of companies, Aon, certainly Cosmos, you and I know. I'm a very big fan of that. All of that is theoretical right now, right? Because none of them are really live with those implementations, but there's certainly a lot of initiatives. And they're individual, right? Everybody's coming up with their own kind of a feature that allows for that. Which one will emerge as a standard? That's a question, right?
Yeah, that's a really interesting point about just practicality and just implementation. Because if you think about protocol, it's just a set of rules that everyone, for whatever reason, believes in. There is a protocol for interoperable crypto exchange, and it's called running an exchange, where you send money, coins to a wallet, and this operator kind of runs this database, and it settles on your path. So Rick, you've worked with decentralized exchanges for quite some time. Do you want to kind of give your perspective on, on how decentralized exchanges can evolve to solve these problems?
Cool. Yeah. So I think decentralized. Well, to sort of flesh out your model a little bit, the difference between what Eugene was talking about with Internet of Blockchains kind of structures and what you're talking about with a centralized exchange is that with the Internet of Blockchain structure, there is no trust, or there is a minimization of trust compared to the centralized exchange. So the centralized exchange is a very clear single point of failure, single point of trust, the exchange itself. And as we've seen historically, centralized exchanges get robbed approximately every 8 months, and it's for tens of millions of dollars, oftentimes, or millions of dollars. So that's a pretty high tax to pay on a centralized exchange facilitating these types of activities. The Internet of Blockchain sort of model suggests, by using blockchain technology itself, a reduction of the risk, and in turn a reduction of the cost of facilitating sort of cross-chain exchanges. Decentralized exchange, broadly as a group of solutions, which is a very large group of solutions at this point, oftentimes relies on a single blockchain to facilitate atomic swaps within that blockchain. So, for example, if you take something like 0x, which is just a settlement layer, it allows you to securely swap like Ether for a Gnosis token between two people who are both on Ethereum. So this is a constrained version of what Eugene was talking about. And in an ideal world, you would have a decentralized exchange that did exactly, which is sort of the union of what the two of you have been talking about. It allows the sort of functionality that Eugene was talking about, but in an exchange context. So you would set a price. I want Ether for Bitcoin. This decentralized exchange framework would allow any counterparty with Bitcoin to facilitate that exchange. Of course, in that case, you have two counterparties with four wallets total. So each counterparty would need to have 2 wallets. And so there's a lot of complexity around that that's sort of being glossed over in the current decentralized exchange space. And I guess I probably should have started off with this. So when we say decentralized exchange, oftentimes, right now we're talking about a decentralized exchange venue, but sometimes when people say decentralized exchange, they actually mean the verb, like to change the assets back and forth, which in finance we call OTC, and in technology otherwise we call P2P, peer-to-peer. So a lot of times when we're talking about decentralized exchange platforms, we could also include systems that just facilitate peer discovery and peers transacting together. And that's more of where I'm focused right now with my decentralized exchange work. I've kind of run through all of these different things with different clients. We've talked about all of these different strategies. And I think that the thing that there's the greatest market demand for and is the easiest to deploy is, simple peer-to-peer discovery. And so there are a couple of platforms that do that right now. BitsQ, I don't quite know how you say it. It used to be called BitSquare, which is much easier to say than BITSQ, but whatever. They're a good example, and also they're a good example because they're Bitcoin based and they're very slow and it doesn't actually work very well. Sorry to whoever, it's a very weird process. You have to have a European bank account and European bank account codes and do all this stuff. It's really weird. Another good example of peer-to-peer, and that's a good example because it's very naive, it's very simple, and it has all these flaws from it being a very simple implementation.
Actually, I just want to preface that particular point because I think, and that's something I want to dig into a little bit, is that, when we think about standards, we think about, ICANN, or we think about like ISO, and kind of a bunch of experts that come together. But there's another way that we see standards which is emerge, which is much more decentralized, which you see a lot more in places like, stock markets or capital markets, where efficiency, what's efficient or isn't becomes very clear. And that's basically market-driven standards. And so you've seen, and I feel like we're just about to get into this, but you've seen like a pretty wide breadth of decentralized cross-chain, interoperability solutions. How do you feel like between a bunch of people trying to come together, writing something like 0x, which is really riff on Ether Delta, yes, versus just the market kind of deciding, because liquidity flows like water, it goes down the most efficient path. Like, how do you see like standard setting body versus the market figuring out what the standard should be?
Yeah, I mean, I think that's a great point. Like, I agree with you that the market should really be making that decision. The problem right now is I don't think there's actually enough knowledge to have a robust market to make an intelligent decision. And I mean intelligent, what I mean is just satisfy its own goals, right? Like efficient pricing. So, and strong interoperability. So I'm a big proponent of Lightning, simply because they've done so much work. And we've actually got some code that does some atomic swaps between Ethereum and Lightning. And we're one of the few projects to have done it. It's called Drawbridge. I don't want to hype projects, I hate doing that, but it's called Drawbridge. It's by Keoken, it's on GitHub. But yeah, I think that Lightning as a standard, and I'm going to get a little technical here, but this whole half of the room is engineers, so it should be fine. Lightning runs on HTLCs, which stands for Hash Time Locked Contract. And that's the benefit of that primitive is that the vast majority of blockchains support it in some way. So if you can just sort of make the small additions you need to that full node, so that, or really to your application running on top of the full node, so that you can process a Lightning style HTLC on a non-Bitcoin blockchain, then you get interoperability that way, which is a very, it's very much like a DIY, like bring your own sort of solution to it, because the Lightning team has no interest in supporting whatever chain you're talking about. But once you support Lightning, you've granted your users on your chain access to all the Bitcoin liquidity, potentially. So I think I mean, that's the strategy that we're kind of going with to start. And it would be nice if, I mean, I think part of the problem with the Bitcoins or the blockchain space is that there's a lot of very excited engineers, which is good, but then they don't necessarily have the best direction. So you see a lot of duplicated effort and like very similar things that are only slightly, they're just different enough that you can't use them together. And there's tons of those in the atomic swap and decentralized exchange space. Like if you look at Decred, I'm sorry, I'm probably gonna get the name wrong, Komodo or Komodo, yeah, I mean, those are just two that just came to mind. Lightning, Raiden, counterfactual to a point. I'm more Ethereum focused. Aeon, as Eugene mentioned. I mean, the list just goes on and on. There are all these projects, and when you actually look at the code, you're like, well, you guys are all basically doing the same. I mean, you're basically all using HTLCs or some other, there's only a couple other forms of atomic swaps. So, I mean, total, there's only 3 types of atomic swaps. HTLCs are far more developed than the other ones. Let's at least all agree on using the same HTLC format and then see if that works or not. And then from there, start diversifying. But we've diversified, and I think this is a natural human inclination, especially when there's VC money floating around. We've diversified a little early, I think. And so we're gonna have a huge die-off. We're gonna have this huge diversity of ways of doing these cross-chain atomic swaps. One of them is going to win. It's almost certain. I mean, in my opinion, I'm biased, but I'm fairly confident it's going to be Lightning. A lot of these other standards are going to either interop with Lightning or go away, and then we'll start to see the shortcomings of the Lightning techniques, because there are shortcomings, and then people will make new innovations after that. But I think before we get that like coalescing point, you should just pick, we should all kind of just try to just naturally move towards like the Schelling point.
Gotcha, yeah, no, that's a great perspective. Yeah, go ahead.
I think that some of the technologies that you brought up, that's interesting because it's focused very heavily around decentralized exchanges or atomic swaps, which translates to management of the fungible tokens. But I think that, especially from the standards standpoint, you need to kind of abstract that further out and look at greater sort of use case that goes beyond atomic swaps and centralized exchanges of fungible tokens, and how do you handle the non-fungible tokens, and so on and so forth. So this is where you need to have a higher level of abstraction in theory, right? To be able to manage, really translate into just how do you swap essentially what comes down to data packets, right? Or pieces of code, right, which can be part of the transaction, so on and so forth. And there is a great model for that, right, that's been already established for years, which is how internet was built. Because initially, if you think about it, there is a lot of symmetry, right? Internet originally started with a bunch of independent networks, Berkeley and MIT and so on and so forth, and they were operating internally, similar to blockchains, and they weren't talking to each other. And not until the emergence of TCP/IP protocols and things like that, that's where we started to really see that connectivity. So when you start kind of taking that model, TCP/IP, and start modeling against that, Internet of Blockchain, you start seeing a lot of similarity, right? At the end of the day, you just want to make sure that you are able to send the packets and have Merkle-proof verifications between the blockchains that, a particular token is being either frozen or burned on this chain and it was recreated on the other, and there's a Merkle proof that goes both ways saying, yep, I got it, or so on and so forth. So this is, I think, what, Cosmos was trying to do. And then even take it further into the concept of internet service providers and creating those hubs and spikes where you can connect those to a central hub, if you will, which in itself is decentralized
central hub.
blockchain of running, relays, right, of creating those, and also, creating those transactions, and then obviously providing some additional benefits of ensuring that there is no double spend problem that occurs when you do the transfer between the chains and so on and so forth. I think that when you kind of sort of step back and start looking at it from that perspective, the model for interchangeability between a blockchain has been invented years ago. It's just a question now of sort of implementing that to some extent, making it more tangible from the blockchain perspective, and seeing who is going to emerge as the leader.
Yeah, that's a great point. I was reading this blog post talking about cross-chain kind of communication. One of them was HTLCs. This blog post was written in 2014. Even then, it's probably an old idea. I kind of want to, so Eugene, I kind of want to take a step back, but in the other direction. So you talked about abstraction. Rick talked about working with lots of excited engineers. You, with Consider It Done, you work with not just excited engineers, but investors, customers, ops people, all risk compliance people, and it's kind of your job to pull these all together and have everyone coordinated on a development direction, right? So what are your views? And you've worked with a lot of projects in this space. So what are your views on if we talk about interoperable standards purely as developing a blockchain project as a standard, but coordinating people to develop towards that standard? What do you feel works well to kind of coordinate people from a project management standpoint to on these decentralized blockchain projects?
Well, what do you mean by coordinating people? I just want to make sure I understand the question.
Meaning that, in terms of, because, Rick gave a good example of we're going to build Lightning, and once Lightning is supported on Bitcoin, Ethereum, and whatever, then this one thing that we built can be used across this entire crypto ecosystem. So just from your experience because you've worked with enterprise chains, you've worked with public chains, you work with stuff like Cosmos, which is cross-chain. Do you feel like there's anything different from working in this kind of decentralized and more open development environment as opposed to the more kind of I'm going to build a product and it's going to work kind of environment? Do you feel like there's more coordination has to be done there?
Right, so from purely developer standpoint, obviously the emergence of the standards simplifies the development process, and certainly when I say simplifies, translates into reduction of cost, right? All the conversations we've had so far are essentially theoretical right now. None of these systems are production ready, they're on testnets and whatnot, but it's, full of bugs and so on and so forth. So from a practical standpoint today, there is already a multitude of use cases that we work with that imply sidechains, right? And a lot of it translates into the cost savings, right? Hashing everything on Ethereum, which is the blah chain, provides the most proof and so on and so forth, it's expensive, right? So how do you reduce the cost? This is where the side chains come into play quite often. You say, right, we'll run all the transactions of our side chain and then batch them up and mash it into the Ethereum. And so that's a practical implication. All of that is essentially today, from a development standpoint, is done, we reinvent the wheel every time, right? there are certain libraries that we can use and draw code from Hub, from Cosmos, so on and so forth, from different open source projects to be able to achieve that. But at the end of the day, it's, long term, it's all going to be throwaway code because it's all, not based on any standards or anything like that. So it will transition into some kind of a platform over time. But right now, it's all basically, fly by the seat of your pants, right? To answer your question.
No, that's a great answer. And there's a piece that I want to dig into, but before I do that, does anyone have any questions for what we discussed so far?
I'm saying something. All right, great.
I have a question. In the beginning, you were talking about centralized and decentralized exchanges. What about the lost opportunity of time in the decentralized exchange with these hash time lock contracts?
Right, so to really break that down for the whole audience, because that's actually a very compact question. When a hash time lock contract is atomic, because the guarantee that what we mean by atomic is that you either get the asset that you wanted or you still have your asset. So if you imagine there's two sides and like there's a red marble and a blue marble, there's no way either party can end up with both the red and the blue marble. They either end up with the red marble or the blue marble, and that's true for both sides. One of the ways that that's asserted in a hash time lock contract is that there's a timeout, there's a time lock. So there's a hash lock and a time lock, and that's why we call it a hash time lock contract. The time lock requires that if one of the parties were to misbehave, you just have to wait it out. And that's where the time opportunity of money is lost, because you had to wait to resolve the dispute in order for the time lock to unlock. So that was a little background for everyone. And the short answer is, depending on the model, so if you're using a prime brokerage model, you can imagine that that when a buyer connects to the prime brokerage over the HTLC, the prime brokerage actually provides a discount in another channel to offset the time opportunity. And so if the first hash HTLC fails and you have to wait for the timeout, you can use that as proof to get an immediate unlock on the other hash lock for the value that you negotiated for the time value of the money. I don't know who I lost or caught in that explanation, but hopefully you caught what I was saying there.
And just from my clarity, it's primarily because there's no concept of time on the blockchain, right? It's everything. It needs to be derived from the concept of what block number you're
Right.
And when you start talking about multiple chains, now you're really sort of in a limbo there. The synchronization point is probably one of the more challenging concepts within the blockchain tech, right? Because there is no such thing.
Right, in a cross-chain atomic swap, your time lock is on the slowest chain,
Right.
which is really brutal because that means you're basically waiting 60 minutes on Bitcoin. And really the channel time locks are much longer than that right now, so I'm sort of imagining it for a trading case. You would shorten that explicitly for trading, but you still can only really get it down to about an hour.
Right, but the idea is that you set your timeouts in block numbers. You say that by the time you reach this block, this is considered a timeout, and at that point you have to either prove that the transaction did not take place or prove that the transaction did take place.
And you have very
otherwise you're timed out.
Yeah, you have very limited resolution. So that's what you're getting at is in a trading case, in a normal exchange, you can say, in 2 nanoseconds or something, this didn't happen the way we wanted it to, give me my refund. In a blockchain case, you have to wait for 60 minutes for everyone to agree on the blockchain consensus about whether you got your money or not before you can start talking about a refund. So yeah, that treatment of time, and the lack of finality in Bitcoin, and also the lack of finality just in proof of work generally, and that lack of finality actually has some huge implications or consequences for people doing trading. Because if you look at something like net settlement, so in a day, there might have been $1 billion worth of trades, but there's only a $500,000 net settlement or $1 million net settlement. And so that really distorts in economic models of security, like economic sort of models of finality, like you have in Bitcoin, that really distorts that model, because if you manipulate the chain at the right time in the right way, you switch this $500,000 settlement into like a $2 billion settlement or some crazy thing, and it's difficult. You can't really use economic modeling on the consensus layer to stop those types of attacks. So that's one of the things that I've spent a lot of time looking at in decentralized exchange research. So sort of go in this little tangent.
So that's really interesting, because it's almost like if the prime broker fronts the money, they can almost kind of cancel out this economic incentive to like stop and cause like net settlement.
That's right. So in that prime broker example, if the prime broker had enough mining capacity, they could interfere with your refund in addition to interfering with the original failed trade.
That's really interesting, because you know, like one of the biggest markets in derivatives is the repo, like overday lending and repo lending, which is generally considered to be zero risk until Lehman came around. And so it's almost like you see this model being reproduced. I mean, obviously the actual model it looks nothing like it, but the idea of giving you really low interest money that is considered to be risk free, which is a prime broker fronting the money, that kind of like comes out again. And I think it's relevant to some people in this room who run funds, because that's one more way to get like a relatively risk-free interest rate on your crypto.
Oh, absolutely. Running a hub, like running a Lightning hub, is like almost certainly for the hub operator risk-free interest. For the counterparties to that hub, they're basically the consensus risk on the parent chain, as I like to call it, can be significant depending on the time opportunity cost of your money.
Right. How are we doing on time? Time's up. Time for one last question.
Yeah, happy to
Last
take
questions?
another question.
It's a meaty topic.
All right.
Cool, you can find us afterwards. We'll be hanging out.
Yeah, I think lunch is lunch next.
Lunch is important.
And then there's the most important section of the conference.
Thank our panelists at Maomao for moderating.